is equal to x plus iy, and here we have three forms or three methods to write the complex number. The first one we call it as Cartesian form. Cartesian form, that is this one, xy axis. Now, Cartesian form means where there are x and y is there. So Cartesian form is z is equal to x plus iy, or z equal to a plus ib, means one real part and one imaginary part. Second form we call it as the polar form. Polar form means we write z is equal to, so polar form we are getting by putting x is equal to r cos theta and y is equal to r sin theta. Then what you are getting is a polar form. That is, therefore z is equal to, here you will get r cos theta, x is r cos theta plus y is r sin theta. So I into y is r sin theta, or that is equal to r into cos theta plus I sin theta. This is the polar form, means where sin and cos are there, that is a polar form. Okay. Then the third form is exponential form. Third form we have the exponential form, or which is otherwise called as Euler's form also. Exponential form, this is given by z is equal to, why we say it as Euler's form, because we know e raised to I theta. This is the Euler's formula. E raised to I theta is cos theta plus I sin theta. So this is the expression for cos theta plus I sin theta is e to the power I theta. So when you write this as, instead of this cos theta plus I sin theta, I will write e raised to I theta. Then this is the exponential form of a complex number. Okay, so these three forms are there. Cartesian form means z equal to x plus iy, and polar form is z equal to r into cos theta plus I sin theta, means you are expressing x and y in terms of r and theta. Okay, and exponential form means we will replace cos theta plus I sin theta with e raised to I theta. So these are the basic three forms of complex numbers. Okay, now here detail of this you had studied in your 11th or 12th. So now here I will just rewind that memory. So first one we have de Mobius theorem. De Mobius theorem, this states that for any rational number n, the value of one of the values of cos theta plus I sin theta, the whole raised to n, is cos n theta plus I sin n theta. Okay, this is de Mobius theorem. That means, you know, here when you take the power, okay, suppose I am finding the solution, say if I am finding the solution of x cube plus 1 equal to 0, then you know we will get three roots, three solutions you will get. Okay, so in the same way, for any rational number n means, if I write say cos theta plus I sin theta raised to, say, rational number means any number of the form p by q. So you know all the numbers means all the natural numbers, when you represent, or all integers we can represent as, express as rational number. So if I say the number 3, then this is 3 by 1. It's a form of a rational number. So this theorem states that for any such rational number, one of the values of cos theta plus I sin theta, the whole raised to n, is equal to, what to do? This n is multiplied with the angle cos n theta plus I sin n theta. there are some more values. Say for example, if I do cos theta plus I sin theta raised to 3, then when you expand this one of the values of that will be cos 3 theta plus I sin 3 theta. What you have done is just this 3 is taken with the angle. So cos 3 theta plus I sin theta, I sin 3 theta. Okay, that is the Mobius theorem. Now before moving on to this one, we need to know some other terms also. So now as a note I will write, so depending on this one, means based on this one we need to do one or two problems also. So not based on this one. See, we know in here we have written z is equal to x plus iy, or z is equal to r into cos theta plus I sin theta, and z equal to r e raised to I theta. Now we will write some expression. Okay, so z is equal to, suppose I write, if z is equal to cos theta plus I sin theta, means using that one only where r equal to 1. If z equal to cos theta plus I sin theta, then z conjugate, otherwise we write z raised to minus 1. Okay, z raised to minus 1 will be what we can write. This is cos theta, means actually this is 1 by z. Okay, 1 by z means z conjugate, or we can write it as z raised to minus 1, and write that also, which is equal to what, 1 by z. Okay, or equal to z conjugate, anything you can write there. So this is equal to, what we do here is cos theta plus I sin theta to the power minus 1, z raised to minus 1. Okay, then by this the Mobius theorem, what we can do is cos minus 1 is taken inside, so it is cos minus theta plus I sin minus theta. Or if you write the conjugate, if I write as that conjugate directly, what you have to do, just change the sign of I. Okay, so both are same only. So if I do like this, means using the Mobius theorem, if I write like this, then this is equal to cos of minus theta. We know cos of minus theta is cos theta only. Cos and sec minus theta is sec theta, cos minus theta is cos theta, remaining all minus will come. Means sin of minus theta will be minus sin theta, then tan of minus theta will be minus tan theta, and so on. Only cos and sec will give positive values. So here sin of minus theta is minus sin theta. So we can write this as plus minus I into sin theta, because sin of minus theta is minus sin theta. Okay. So now this plus or minus will become here minus. So directly if you are writing this one, z equal to cos theta plus I sin theta, then z conjugate will be what, just change the sign. Z conjugate is cos theta minus I sin theta. So either of this you can use. Okay. So whatever, if you do this, take this, and directly if you write conjugate, then just change the sign of I. Okay, so both we can write, both you can use. Therefore we have this. Now if I do z plus 1 by z, just see what it is. Z plus 1 by z will be, z is this cos theta plus I sin theta, cos theta plus I sin theta, and 1 by z is cos theta minus I sin theta. Okay, now this is equal to what, see, plus I sin theta minus I sin theta, we can cancel. So cos theta plus cos theta, you are getting 2 times cos theta. So that is z plus 1 by z. So this you have to learn as a formula. Z plus 1 by z is equal to cos theta plus 2 cos theta. Similarly, if I write z minus 1 by z, z minus 1 by z means if I subtract this and this, what you will get, this is, here negative sign will come, z minus 1 by z. So what will happen, this cos theta will get cancelled. Then I sin theta minus I sin theta means I sin theta plus I sin theta you will get, and you will be getting 2I sin theta. Okay, so these two formula you have to remember, you have to learn this. Or You can just write even sin theta cos theta also, means if I want to just write cos theta, then it will be z plus 1 by z divided by 2, and only sin theta, then 1 by 2i of this one. You can take 2i to the denominator, so this one. Okay, now after this what you have to see is, now if the same one, so this is we have taken the z. Now if I take z raised to n, z raised to n, the same way if I do cos theta plus I sin theta the whole raised to n it is, which is otherwise cos n theta plus I sin n theta using the Mobius theorem. We are taking this n into or multiplying that with the angle. So here also using the same concept. Again if I write z raised to minus n, you will get cos n theta minus I sin n theta. Okay, this is generalized form of this one. This is z raised to 1 plus 1 by z raised to 1. So this one is generalized form of that one. Therefore here if I write z plus z raised to n plus 1 by z raised to n, this will be 2 times cos, see when you add these two, this and this, when you add sin n theta will get cancelled, you will get 2 cos n theta, and similarly z raised to n minus 1 by z raised to n will be 2i sin n theta. Okay, now here using this we will be using in some problems. Suppose we have to find z cube plus 1 by z cube. So what will happen here? This is 2 cos 3 theta. Okay, so like this application we will be doing in some of the problems. So for that purpose you need to learn this. This also general form of this, generalized form. Okay, then the next term here what we use is, in college you might have studied modulus amplitude form. Okay, so modulus amplitude form means, even though we don't have that, just I will tell you what it is. Modulus amplitude form of a complex number. Modulus amplitude, actually this is modulus amplitude form. Which one? This, z equal to r into cos theta plus I sin theta. Here r is the modulus and theta is the amplitude, means angle. Okay, then we use Argand diagram to represent this and all. So here just I will tell you how to represent it in the modulus amplitude form. So if I have, say I have a number, say 1, we need to represent this 1 as modulus amplitude form, or say 1 plus I want to represent as modulus amplitude form. Then what we used to do is, this is, let this is equal to 1 in r into cos theta plus I sin theta. I hope you know this. Okay, r into cos theta plus I sin theta. Then what we used to do is, this is equal to, we'll just open this bracket, r cos theta plus I into r sin theta. This is 1 plus I. Then equating the real and imaginary parts. Equating real and imaginary parts on both sides. What you will get? Real part means, here 1 is the real part. Real part means where there is no I. And here it is r cos theta. So you will be writing r cos theta is equal to 1. And imaginary part is where there is I. So here it is r sin theta. R sin theta equal to, on the left side, here it is I. I means it is actually I into 1. Okay. So I into 1 means the coefficient there is 1. Then what we used to do, we will take this as equation number 1 and 2. Then we will square and add. 1 square plus 2 square you will do. Okay. 1 square is r square cos square theta equal to 1. Equation 1 we are squaring. So left side square is r square cos square theta, right side square is 1 square, and equation number 2, when you square that one, r square sin square theta. equal to, and here when you square this right side, means we are just squaring and adding equation 1 and 2. Equation 1 or 2 we are squaring and then we are adding. So 1 square plus 2 square. This will give you r square cos square theta plus r square sin square theta is 1 square plus 1 square. Or when you take r square common from here, this is r square into cos square theta plus sin square theta equal to 1 square plus 1 square is 2. Okay, therefore we know cos square theta plus sin square theta is 1. Therefore we can write here r square equal to 2, or r is equal to plus or minus root 2 will come, but here r being the modulus, r being the length, you will be considering only the positive value. Okay, so that is root 2 we will take. Then to get theta, what we used to do is equation number 2 divided by equation number 1. So that is equation number 2 is r sin theta divided by r cos theta equal to 1 by 1. So therefore r cancel, you will get tan theta. Tan theta is 1, therefore theta will be tan inverse 1. Means value of tan for which it is 1. We know it is pi by 4, 45 degree. Tan 45 is 1, so theta is pi by 4. Therefore what you will write, therefore 1 plus I. We have taken 1 plus I equal to r into cos theta plus I sin theta. Okay, so that is r into r means root 2 into cos pi by 4 plus I sin pi by 4. There are some rules to find this theta. Now here both are positive. R cos theta is positive, R sin theta is positive. So this will come in the first quadrant. So it is pi by 4. Okay, so now root 2 into cos pi by 4 plus I sin pi by 4. This is the modulus amplitude form. Means modulus also you got, argument also you got, angle also you got. So this is a modulus amplitude form. Now this can be represented as, now here this is root 2. Now we know e raised to I theta. This is what I wanted to say actually. That is why it came like this. So e raised to I theta, we have cos theta, Euler's form, cos theta plus I sin theta. Means when it is theta here, it is taken here. Means if it is e raised to say I 2 theta, then this will be cos 2 theta plus I sin 2 theta. Okay, same way, if it is cos theta, here theta is pi by 4, here also theta is pi by 4. So I can write this as e to the power I pi by 4. Okay, so this is the exponential form. Means if I have a term, say for example, suppose I have something like say root 3 into cos pi by 3 plus I sin pi by 3. Then this will be equal to e to the power root 3 into e to the power, theta is pi by 3 here. Okay, I pi by 3. Or if it is given, say e raised to I pi by 7 if it is given, this means that this is cos pi by 7 plus I sin pi by 7. So this is useful while doing the Mobius problem. So like this we can write.